My name is Meredith. I'm the co-founder and CEO at Stork Labs. We're the main development company behind Stork, a decentralized Oracle network. And I'm very excited to be here today, so thanks for having me. I will be diving into why the old way of doing business for oracles no longer works today, or I guess a little bit more strongly, is dead. And before we actually dive into the business models, though, we're going to lay some of the groundwork or foundational understanding of what an oracle is and how it's used. Oracles were created essentially to connect blockchains to external systems. The way that you can think about an external system is anything that's happening outside of the blockchain itself. That can apply to off-chain data, or it can even apply to what's happening on another blockchain, but for the purposes of this presentation, we're going to be focused on off-chain data. And to dive into really how blockchain or oracles are used on blockchains, back in 2020, 2021, the first use case with real product market fit was leveraging oracles to provide the price feeds of major cryptocurrencies for lending protocols so that they could evaluate collateral positions. And just to remind ourselves of what blockchain ecosystem looked like at that time, we only had a handful of blockchains coming to market. We only anticipated a handful existing. It was incredibly expensive to launch these blockchains, so a lot of the new folks coming into the space after Ethereum mainnet and Solana were raising tons and tons of capital. And also, these lending protocols themselves were only accepting collateral positions for the major cryptocurrencies. So you could imagine, the top 10, top 15 cryptocurrencies would actually be accepted. So what that actually looked like in terms of a product for oracles to support was periodic updates on what is the price of Bitcoin or Ethereum or Sol, and putting that on a single blockchain every few hours, varying from 6, 12, even sometimes every 24 hours if there wasn't a lot of volatility in the market. And I'm not going to get too into the weeds of what the architecture looked like, but I do think it's important to just give a high-level overview of when an oracle wanted to integrate with a blockchain, it would basically have to stand up infrastructure from the ground up for each individual blockchain. So what we're looking at here is an oracle integrating with a single blockchain. And the important piece here is really looking at that third row where it says publisher. So sometimes referred to as a data publisher or an oracle node operator. But either way, this publisher would put data directly on the blockchain. So in the instance or example of a lending protocol trying to evaluate collateral, you could imagine each of these three publishers is publishing the price of BTC at a given time on the blockchain that they're integrating with. And then from there would be a smart contract on the chain that would aggregate that data, determine what is the actual price, oftentimes a median calculation, and then store it to that contract, which then can be queried by dApps themselves, or decentralized applications. So, the things to take away from this, though, are basically if I'm an oracle and I want to integrate with 2 chains, I have to rebuild this entire stack twice. If I want to integrate with 5 chains, 5 times. So that means your costs increase linearly every time you integrate with a new chain. Also, gas at this time was pretty expensive, and the publishers were bearing the cost of each. So basically, the outcome of this is it's actually quite expensive to integrate with a new chain, and there's a lot of pressure to limit the amount of data that's getting put on chain in order to keep costs in line. Okay, so this model doesn't work anymore, and given that we're not in 2021 anymore, I'm sure everyone kind of has an inkling why, but just to lay it out, we have seen an absolute proliferation of new chains. We no longer live in a world where maybe there will be 10 legitimate blockchains. Instead, we're seeing hundreds now and anticipate thousands. So what's happening alongside this is basically it's becoming increasingly cheaper and easier to launch a new blockchain. And, we used to think of a blockchain being this general purpose chain where you could have thousands of applications building on top of it. So if you're an Oracle putting data on that chain, you're basically thinking of this as a public good, right? So I'm going to put the price of or my network is going to put the price of Bitcoin on this chain, and now thousands of applications can leverage that price point. And as a result, oracles would actually charge millions of dollars to integrate with a single chain. But we're seeing this shift in market. While yes, we still have general blockchains, but we also see specialized blockchains or app chains where they're catering to a smaller number of applications or perhaps their own application, in which case spending millions of dollars for an Oracle integration makes no sense. Just to further iterate the point, there are a number of roll-ups as a service companies now. You could think Gelato, Caldera, Conduit, a number of others that make it incredibly easy and cheap to launch a blockchain or a roll-up. Basically, you can do it in a matter of minutes, sometimes even seconds. And if you're on testnet, you might not be paying a single dollar in order to do so. So if you're thinking about additional infrastructure that you need to integrate with your own chain, you're obviously going to expect that you can integrate it almost as fast and also incredibly cheap. Okay, so beyond new chains, why else is this architecture that we saw on the previous slide, why doesn't it work? Well, it wasn't designed to support low latency apps. As I mentioned, you only see updates every 6, 12, 24 hours. And as a result, the entire end-to-end flow of getting that data on chain could take several seconds, and that wasn't seen as a massive trade-off. But we now see, an increase of many dApps that are focused on real time, as well as chains themselves. In 2022, we started to see a surge of decentralized perps come to market, and that has only taken off since. There's now 100 plus decentralized perps, and all of them are thinking about how can I get data as fast as possible to ensure that I'm minimizing risk on my platform. Similarly, we have a number of low latency, real-time L2s and L1s coming to market, who are all thinking, we want to be able to provide a UX to the end users here that is competitive with Web 2. And so what that means is things need to happen as low latency as possible. We're seeing block times that are sub 1 second, some even touting 50 millisecond latency or block times. And then we're with Mega ETH, we're seeing some real-time blockchains in being built as well. So that means that the data that's being fed into those systems needs to be able to keep up as well, and that's incredibly hard to retrofit into something that wasn't designed for speed. And then the last one is we're seeing just new use cases come to market. So the old model was really designed for this singular use case. It was quite rigid, and it didn't support a lot of different data types. So as we try to bring new primitives to the space, new use cases for applications, that comes with that are requirements for new types of data. So enter Stork. I won't bog us down too much with all the details of what's happening in the architecture here, but I'll just talk about it at a high level from left to right, some of the innovations that we've made that we think address these problems. So first of all, overall, we've modularized the stack. And so what that means is, as a first-class citizen, we want this Oracle to be incredibly composable and support the unique needs of anyone who wants to partner with us. And we also want to be able to leverage our stack to integrate with every chain in the future. So we anticipate a world where there could be thousands or tens of thousands of chains, and it can be incredibly easy for Stork to scale to support all of them. So on the left-hand side of the screen, you can see this concept of a publisher, which we mentioned before. What we've introduced is this publisher agent. And basically, the idea behind it is there's an easy one-time setup for anyone who wants to provide data to our Oracle network. And after doing that, their data can be used on any chain. So it's one-time setup. And it's incredibly easy to get started. We've had some publishers get up and running in production in less than an hour. The second piece here is we've introduced an off-chain aggregator. And instead of relying everything to go on chain for verifiability, we rely on cryptographic signatures throughout the stack so that there's still traceability and you can minimize any trust assumptions. But what this means is that one aggregator can support many, many chains, or an infinite number of chains. And in order to make this actually work, the key piece is that subscribers actually have the tooling themselves. You can think of a subscriber as either a chain or a decentralized application to put data on chain themselves, and that's labeled as a chain pusher. And basically what that means is we can support an incredibly high frequency of data, of throughput, of updates, and the individual applications can determine when they actually need a data point put on chain for their unique use case. Overall, what this unlocks is we can scale infinitely without worrying about added costs, and we can cater to very unique use cases. Okay, so just to double click into some of the things I mentioned there, really the unlocks here are we have support for high performance real-time feeds. What that looks like in practice is most of our data feeds have updates every 250 milliseconds to 500 milliseconds, as well as can support conditions based off of a change in value. So for instance, a lot of the data feeds we support update if there's a 10 basis points change in price. The architecture itself is intended to be composable and non-opinionated, so that means, again, we can flex into unique use cases, which I'll highlight in just a bit. Again, easy setup for new data providers, which again makes it incredibly easy for us to support new types of assets and new use cases. We've also built out programmatic chain deploys. So basically, there is a piece of this architecture that lives on chain for verifying and storing the updates so that they can be used by any dApp. And we can have any of our smart contracts deployed programmatically via API. For example, we have an integration with Gelato, who's a roll-up as a service provider. And their clients don't even have to get directly in contact with Stork in order to include us in their app chains or roll-ups. Again, unlimited data catalog. And I think the most important piece here is this stack, because it was built to scale, can actually be made available at a reasonable cost to developers, to applications, to chains, based on what their use case is. So they don't have to worry about that millions of dollars of overhead or have to raise millions of dollars in order to bring on an Oracle partner. So, I've talked a lot about, or I've mentioned a lot about new use cases being supported. This is really what gets us incredibly excited and what I see as real differentiator for Stork. So just some examples that I'd like to highlight today. In 2022, the first example we actually brought to market with a new type of data feed supported were mark prices. So for those not familiar, a mark price is basically something that is used by most of the major centralized perpetual exchanges. And they use it to determine when to trigger a liquidation. For those who haven't actually trade perps themselves, these can be offered with 10, 20, 50, 100x leverage. So it means that they're actually very sensitive to small changes in price. And the exchange itself can be at risk if they don't trigger a liquidation quick enough because they could get stuck with the bad debt. Why do we want mark prices? That said, we want to protect the user experience. We want to make sure that we don't ever trigger a liquidation that shouldn't have happened. And basically, mark prices are used to smooth out scam wicks that can happen with very volatile assets. And so we were the first and only Oracle to bring mark prices to market for decentralized applications. These are just 4 apps that are using it now: Vertex, Apex Pro, BSX, and Rhea. But many others are as well, and we're still the only Oracle that actually supports these today. A bit more niche and exciting as well is we're partnering with Helix, which is the native DEX on Injective, the blockchain. And they've actually built entirely custom indices using Stork Stack so that they could offer new financial products to their customer base and help encourage onboarding new institutions into the space as well. A couple of those examples include they have a market for the BITL fund, which is BlackRock's fund that, and basically it tracks the market cap of it and allows folks to trade perps on top of that. And they also have a custom AI index, which tracks the market capitalization of both cryptocurrencies and equities that are in the AI space. We're also doing a number of other projects with them, and very excited about the work that's being done there. We anticipate it will onboard a lot of new folks to the space as users. And then lastly, in terms of examples for today, we onboarded Kalshi as a data provider last year, right before the election. And for those that aren't familiar with Kalshi, they were the first CFTC-regulated prediction market in the United States. They were the first exchange or marketplace in the US that could legally offer prediction markets on the presidential election in over 100 years. And leading up to November, there was obviously a lot of excitement and anticipation about how that election was going to go. So they actually integrated with Stork because of how lightweight it was and wanting to build upon their relationship with blockchain applications. And so they provided data feeds so that applications could actually offer products on top of what is the result of the presidential election. Helix actually was a partner who leveraged those feeds, as well as D8X and a number of other exchanges too. Just some highlight stats just to kind of iterate, what adoption has looked like for this model that is quite different from the traditional Oracle model. Up in the top left-hand corner, we have total transaction value, which is essentially a measure of total volume traded on the exchanges that leverage Stork. So, massive amount. We've supported over $600 billion in volume traded over the last couple of years with our data feeds. We just rolled out the programmatic deploy for chains, as I mentioned. And in the bottom left-hand corner, we've now integrated with 50 chains, and we anticipate this number to accelerate rapidly. I think last week we integrated with 4 chains in a single day. We're supporting over 375 data feeds. We have very low latency, as I mentioned. End-to-end, the stack has under 10 milliseconds of latency, and we're supporting massive throughput or scale of data, just under 70 million updates a day. Just wanted to highlight some of the additional brands that I didn't mention earlier that are part of the ecosystem across both decentralized applications that are using our feeds, as well as the many chains that we're partnering with. And yeah, that's the presentation. We're really excited about a future where folks are able to get access to the data that they need at a reasonable rate, where oracles are no longer a blocker for innovation. And thank you for letting me walk you through all of that. If anyone is interested in partnering with us or learning more, our Twitter handle is @StorkOracle, and my email address is meredith@stork.network. Thank you.